Hi everyone, so I'm going to start with a quick demonstration of how to use Agisoft Metashape. So here we can see a layout of what Metashape looks like. So at the top you have all of your tools that you can use. On the left you have your workspace and it'll have information as different layers, data layers start getting created. On the bottom you have the images once they get loaded in, and in the center here you have your main viewer for once you have models to view and interact with them. So the first thing that I'm going to start with is looking at my settings, which I'm going to look at under tools and then preferences. So I'm going to start this and just look at a few things that I'm interested in. The first thing is looking at this GPU tab. So for those of you that have computer setups and you have graphics cards that are installed in it, you just want to make sure that those are visible here and checked so that they are in use. The second thing that I'll look at is the advanced tab. And the things that I want to check here, which is great, they aren't checked, just to double check, is to check the two boxes that say keep key points and keep depth maps. And what those two settings are going to do, the first one, key points, saves the key points in the alignment phase. So that way, if we forget images or not all of them align, since we have those saved, it can do more of an incremental image alignment. And so you don't have to restart from scratch every time. The second thing is to keep the depth maps, which is something that's generated during the build dense point cloud phase and can be used for other tools too. It's a pretty time intensive step, so useful to save those data layers so that they don't have to get recreated over and over and over again. So it'll definitely save you time down the road. So those are two things that I recommend making sure they are on. I'm going to apply those settings. And that's pretty much all I'll look at for the initial settings. Then I'm going to start off by adding in my images. So to do that, I'm going to go to workflow up here at the top. I like to organize all of my images into a single folder, and that can be in folders within a single folder. As long as there's one hierarchical folder where within that is all the images that you want to add into the project, and ideally doesn't include images that you don't want to add, but we can delete those later on. So I'm going to select that folder, find the folder of images that I want to add in. This is my folder here. I'm going to hit select folder, and then it will quickly, depending on how many images you have, load those in. Then this prompt will come up asking you, depending on if there were any subfolders within that main folder, there will be some different options, but generally all the time I use the single cameras option, where all images go into a single chunk and each image file becomes a single camera. And then you'll see here at the bottom, my images are now loaded in. The first thing that I'll do is take a look through these images and look through. It might take some time for the thumbnails to load, depending on what drive they're on, how many images you have. You know, if they're over a network, maybe they might load a little bit slowly, but I'm just looking through here and looking for any images like you saw at the top. Actually, I'll go back up and delete these. So these first two are some of the calibration photos, or examples of calibration photos. These are photos that we don't want to get matched and go into building the model. So I'm just going to select those two, and you can either disable them if you want to keep them in this project file, or select remove cameras here if you just want to get rid of those images entirely. So in this case, I'm just going to get rid of them entirely. So hit remove cameras, and now you can see those files are gone. So I'll continue looking through these images, looking for anything similar like that. So whether they're calibration photos, maybe another diver got in the way and is blocking the view of the bottom, and you want to take those out, or maybe at some point the camera got flipped up and you see a lot of the blue water, which is going to create a lot of noise. Those sorts of images are things that we want to filter out at this point. And you can do it at this point when they're loaded into the project file, or you can do it before you even load the images in. Doing it this way is really nice. That way you can save those images. You're not permanently deleting them or having to move them around or keep them in a different folder somewhere. It just makes sometimes the image organization a little bit easier. Cool, so I've gone and looked through all of my images and I'm happy with everything that's in there. So step one of the structure for motion pipeline is to align the images. So I'm going to go up here at the top, workflow, align images. And you can see some of the settings here that Johnny went through in his lecture. And I'm just going to click OK. And now it's going to go through. The first step is to go through all those images and detect points. So essentially looking for features within the images to match. All right, now we cut forward to the next step where you can see that it says matching points now. So based on all of those features or points that it detected in each of the images, it's going to go through image by image and try and match features from one image to another. And now we'll skip ahead to the final step in the alignment, which is to estimate the camera location. So essentially it's taking all of those matches that it's found between different images and using that to estimate where each camera was located, or where the camera was located when each image was taken based on those matches to create the alignment. So this is the true aligning part of the first step in Metashape, which is align photos. All right, so now we can see here that the alignment is done and we have our sparse point cloud, which Metashape refers to as tie points. To navigate around and see this model, you can use scroll to zoom in and out. Left click will kind of drag and navigate around. Right click will pan the model around, and then a double left click will target and center the model on that point that you clicked on. Those are some of the navigation. So some of the things that I'll look at here is just looking at how many of those images aligned. Do I have close to 100%? You won't always necessarily get all of the images aligned. You just want to make sure that there aren't significant portions of those images that didn't make it. In that case, if you did, then you would want to do the alignment again. And because you check that box to keep the key points, it'll save this existing alignment and then just try and any of those images that didn't get aligned, it'll just try and add them to it. So at this point, I'll look and see my model and get ready for the next step. You can do some adjustments and optimization, which we'll go through later in this course. But for now, we'll take this model and just get it ready for the next step, which is to build the dense point cloud. So the first thing that I see here is that you have this bounding box, which is a cube you can see outlined in black and red. One thing that I'm noticing is maybe some of the corners of this plot. This one is not too bad, but you can get some instances where significant portions of the plot may fall outside of what's called here the bounding box. And so I'm just going to make sure and adjust my bounding box right here to ensure that the whole model is in view. So I'm going to use these tools up here, and you can see there are these options for the region. So the first thing that I'm going to do is I kind of have a square plot here and a square bounding box, but they are offset on the diagonal. So I'm going to use this rotate region, and now you'll see the bounding box becomes a little bit more in focus here and defined. And so I'm just going to left click and drag to rotate my bounding box to be more in alignment with the square of my plot. Then I'm going to go back to resize region. And when you're in resize region option, you can navigate and pan around. When you were in that rotate region box, the clicking and dragging moves the region as opposed to letting you navigate around. So I'll use this, and now you can see a little bit of this top side might be a little bit off. So I'm going to click on one of these spheres that's in the corner of this bounding box and use that to drag and expand my region. And just making sure that all the areas of this model lie within that bounding box. Essentially, any areas of this sparse point cloud that fall outside of that bounding box is not going to get reconstructed in further downstream steps. So you can use it to crop a model too. So if there's a specific smaller area within here that you wanted to only reconstruct moving forward, you could shrink down this bounding box to meet that size. But in this case, I want to reconstruct the whole thing. So now we'll move on to my next step, which is the step to create our 3D model. in the form of a dense point cloud. So I'm going to go back to workflow, which is where all the steps are, and now select build dense point cloud. And this dialog box will pop up. You can change the settings how you like and select OK. And so now it'll start off by loading the photos, and then it'll, which should be a fairly quick process, and then it'll move into the first step of building the dense point cloud. All right, so now we can see that the images have been loaded, and now it's on to the first step of the build dense point cloud step, which is generating those depth maps. So essentially for each image, it'll go through and create a depth profile of where each pixel is in terms of distance to the camera. And this will be the first step in kind of filling in those gaps. The sparse cloud, if you were to zoom in and look around, you won't see any details. There's a lot of gaps because, you know, as the name suggests, it is a sparse point cloud. And now we're going to fill in with those gaps and some of the finer structures. And the first step of that is generating those depth maps. Once Agisoft has moved on from creating the depth maps, which as you can see is a long process, the next step will be to filter through those depth maps, looking for noisy points and trying to filter them out. The filtering depth maps is also a long time intensive step before it moves on to the final step, which will be actually building that dense point cloud and filling in those points. Once all those steps are complete, you'll end up with this final product here, which you can see is the dense point cloud. So you can see on the workspace over here on the left, it lists out all the different steps and products resulting from those steps here on the left. So the first one being the tie points, which is also I'll refer to here as the sparse point cloud. So you can see as I switch over to looking at the dense point cloud here, much higher density of points, which is why we refer to those tie points as a sparse point cloud. So now here, this dense point cloud, this is going to be the final product. So we have our 3D model. We can zoom in and see all the details of the reef on the bottom. And those are the steps to creating a 3D model in Agisoft Metashape.